Today we are going to discuss about something else which is pretty simple but yet it is widely used. Isn't this an LED which I have already talked about? Yeah, you are right. This is an LED. But it's not an ordinary LED. It has some superpowers. It's called an infrared light emitting diode or IR LED. I forgot about something else. Yeah, let's get to the intro. This is an IR LED which is sort of bluish in color. There is also another one which pretty much looks like an ordinary light emitting diode. The working of the IR LED is similar to the light emitting diodes. So if you don't know much about light emitting diodes and stuff like that, then you may click right here. Yeah, over there. Let's dive deeper. If you apply a voltage to this IR LED over here, you will not see this LED lighting up. It's not because of the fact that this LED is dead. It's because that we humans can only see a specific range of electromagnetic radiation spectrum. So we cannot see the infrared rays. And the electromagnetic spectrum means the range of frequencies of electromagnetic radiations, their wavelengths, photons, etc., and stuff like that. You don't have to dwell into that. So you just understand that different colors have different wavelengths. So likely the infrared also have a different sort of wavelength. We can only see light rays ranges from 380 nanometer to 750 nanometer. And for violet it is 380 nanometer and for red it is 750 nanometer. But the infrared ranges from 700 nanometer to 1 millimeter. So we cannot see it. So if I apply a voltage to this thing over here, you will not see anything happening. It's because what? You can see it? Oh my god! I think you got superpowers. Nah, I was just joking. It's not your power. It's the power of the camera. The camera can see the infrared rays. Now, how is this IR rays produced? Depends on the chemical used in it. These are usually made of something called gallium arsenide or aluminium gallium arsenide. So if you want to make a different sort of LED, then you have to change the chemical. For example, if you want to make a red or amber colored LED, then you have to use something called aluminium indium gallium phosphide. This is called an IR receiver, which receives the IR rays falling on it. We generally use it with an IR LED to make use it as an IR sensor. There are also other variants of this thing called TSOP, which is a three-legged component. One thing to remember while using this IR photodiode is that we cannot change it with a ordinary photodiode because it will collect light from other sources too. The infrared rays are opaque to visible light while they are transparent to infrared. The IR sensor consists of two parts. One is the transmitter circuit, another one is the receiver circuit. The one which transmits or emits the IR rays are the transmitter, which is abbreviated as TX, and the one which collects or receives the IR rays are called the IR receiver or IR photodiode, and receive is abbreviated as RX. Over here, I have a simple IR sensor circuit using a transistor. This is not a super circuit because we cannot change its intensity or strength or sort of things like that. But we can make a better circuit by connecting it with an op-amp LM74 or LM35. But for pedagogical purpose, this is fine. If I apply a voltage to this circuit, the IR transmitter will transmit the IR rays and it will be received by this photodiode. The transistor acts like a switch. I'll talk about it in another video, and the buzzer turns on. So if I apply this voltage, you can hear the buzzer. So if I bring an opaque object in between these two, the buzzer turns off. It is because now the IR rays aren't falling on this photodiode, so it cannot produce sufficient voltage to turn on the buzzer. So if I move it back, you can hear the sound again. See it? The IR photodiode's resistance and output voltage changes in respect with the amount of IR light it received from this transmitter. And that's what happened when I brought this opaque object in between them. Now the amount of IR light it received from this transmitter significantly drops. Therefore, the produced voltage also significantly dropped. So when I took it off, the amount of light falling on it became greater. So the output voltage also became greater. Here the circuit is configured in direct incidence because the IR LED is placed directly in front of this IR photodiode. So now the IR rays fall directly onto the receiver. I'll show you another configuration. Here I have a different configuration. This configuration is called indirect incidence because no IR rays are falling directly to this photodiode. In this configuration, if I bring something else bright colored like this one, the IR rays will be reflected on it and it will fall on this photodiode. So let's have a look. See? But if I bring something else dark colored, it won't make it because dark colored materials will absorb the IR rays falling on it. So it won't make that. So if I bring it, see? It is because the IR rays are reflecting on it and it will fall on the IR photodiode. The sun also produces infrared rays. Roughly half of its energy is in the form of infrared. There are so many other sorts of sources of infrared, like for example, heating devices also emits infrared rays. IR music transmitter and receiver, item counter, line following robot, infrared cameras, visitor counter, and what to say, even this thing that we use daily, the remote, even have the IR transmitter. It has so many applications. As I have said, it is simple but have so many wide-ranging applications. You need to think how amazing these things are. Thank you for watching, and this is me, the Prakash. I'll catch you in the next one.